I just hope I'm audible. Audible. Yeah. Yeah, I think I should be audible now. Yes. I can confirm that I'm audible now and we are live. Just let me just let me just pin notify everyone. Okay. Awesome. So if anyone wants to join the stream, let me know. I'll share a meet link and then you can jump in. But otherwise, the idea today is to take a look at a project which has been made by one of the community members, Ravi. So Ravi's been on the stream a couple of times, and he basically has his own amazing YouTube channel as well. And he mostly makes tech, like he mostly makes hardware and firmware and everything around that for tracking devices. So, for example, you want to buy a car tracking device, Ravi is your man. So, yeah, his website is valetron.com, where you can see some of his older projects. The latest one is this one, which we're going to take a look at today. So this is the Valtrack V4. It's going to be launched on Crowd Supply pretty soon, and it's a 4G LTE GPS vehicle tracker with Bluetooth and Wi-Fi connectivity. So it's got an ESP32C3 on board, which is a RISC-V microcontroller from Espressif, and then he's got a 4G modem with it and a SIM card slot, yada yada yada. We'll take a look at all of that, but this is the one that we're going to be taking a look at today. Hey. All right. So I first pinged Ravi because one of my neighbors wanted this uh, for their kid because they were a little worried about their kid and their needs, and they wanted to keep a tracker in their bag. The kid is actually quite small, so they just wanted something like that. And I had AirTags, but they were not an iOS user or an iPhone user, so AirTags wouldn't work for them. So I was looking for something, and that's when I pinged Ravi, and he said that if you wait for a couple of days, he's got a new version of the Valtrack tracker. I think the older version was based on some microcontroller which is hard to get now. I think it was one of the STM32s or something like that. But the new one is based on ESP32C3, and that's the one that's going to be crowd-funded pretty soon on Crowd Supply. Uh, Awesome. So this is the documentation link that he sent me, and this has got a bunch of stuff, including firmware schematics, in general, how to power the board and all of that. So I've tried it out a little bit already, but what I'm going to do in the next 25 minutes is not going to be very comprehensive, but the plan is that I'm going to do maybe one or two more videos on this because one thing that I want to do is add Zephyr support for this because that's something that I've been playing around with recently, and I spoke to Ravi and that's not there yet, so this would be a great way for me to get familiar with this particular hardware. The good thing is yeah, ESP32C3 is already supported. So most of the hard work has already been done probably by the guys at Espressif. Uh, so it's going to be probably just a question of adding a device tree file for Zephyr for this particular board, which I think would be a nice way for me to get familiar with the Zephyr device trees as well. I've used them once, but that wasn't very comprehensive. Yeah, the older version of this was based on an STM32WB55CU. And I'm guessing in the last 2 years, those basically became unavailable or became extremely expensive. All right, let's take a look at this first. So it's a low power vehicle tracking system. So this is, yeah, this is the one that I have. I think I've put the lid on backwards, but this is the version that he sent me, and this is, I think this is still something that he's manufacturing by hand. I don't think he has started mass manufacturing of these yet. I think that's why he has the crowd supply project up. Let's take a look at the features. And then what we can do is once we take a look at the features, we can just open this up, take a look inside, and then just connect to it and see what we can get from it. So far, I haven't made any changes to the firmware, so this has the stock firmware, which is also available on GitHub. Awesome. So this is the power diagram and what takes precedence. You can see there's a switching regulator, a battery charger, and it also has. I didn't know there's an accelerometer here as well, and the cellular module. Perfect. So yeah, you can power it from 12 to 42 volts, which is why I have this here. I'm going to power it using a 12 volt supply, but I can also power it using a LiPo battery, single cell, because 3.7 to 4.2 volts, and at least 400 milliamp hour. All right. Yeah, I didn't expect it to be like a really low power thing like the Apple AirTag because this is a cellular modem and 4G that too. The Apple AirTag uses Bluetooth and their own custom radio, I believe, and that's why it runs off a coin cell for a year or whatever. But this is like a completely different thing. This is more enterprise or industrial. The AirTag doesn't have those kind of things. Like even the experience of using AirTag from an app is very poor, I would say. It works, but it's very poor. This is more, that's a consumer product, I think, and this is more of an enterprise or an industrial product. Even the case feels very rugged. I tweeted about it a little earlier. We'll take a look at that, but let's take a look at the specifications before we jump into the hardware. Yeah, 12 to 42 volts, reverse polarity on the 12 volt connection, but the battery doesn't have reverse polarity. So if you plug in the battery incorrectly, you're gonna have trouble, but that rarely happens because you have that standard connector. So unless you have soldered a connector incorrectly, you should be okay. PCB dimensions, enclosure dimensions, cellular module. Okay, so it's 4G and a backup of 2G, I believe. I think I have the 7672S for Indonesia. It's got an inbuilt GNSS. GNSS hardware is so people use GPS and GNSS, I think, interchangeably, but yeah, it's something along those lines. Aux input, okay. Yeah, this is all thanks to all the awesome stuff that ESP-IDF has, the Espressif SDK, uh, Bluetooth yet to be implemented. Uh, yeah, this could be actually easily done if you take a look at the ESP Rainmaker uh, application, so that can be a good way to get the Bluetooth functionality here. Akshay has pointed out in the chat that AirTag has an NRF52. It's quite interesting. I know that Apple acquired uh, some part of Dialog Semiconductor, so I was kind of expecting that the AirTag would have one of their own chips. I didn't realize that they're using an off-the-shelf Nordic. But yeah, Nordic does great stuff when it comes to low power, so I wouldn't be surprised either. Okay, so coming back to Valtrack V4, we have ESP32C3. This is the FH4 variant. I'm not sure what the F and H stand for. Let's take a look at this. This is the data sheet for ESP32. Alright, we are looking for FH4. Yeah, okay, so the FH4 is like the 4MB QFN32 version, which has 22 GPIs available, and there's an AZ version which is 16. So yeah, this comes with embedded flash, which is good because that means that we can make this PCB as small as possible. Hey Anshuman, uh, so this is the FH4 variant with the inbuilt flash. Awesome. And RISC-V, yeah, so I think this is the first RISC-V chip from Espressif, and they have many more coming in, but I think this was the first one, so, if I remember correctly. And I think the idea is that the C3 is kind of like a replacement for the 8266, so it doesn't have as many GPIOs as the regular ESP32. If you want something along those lines, then I think you look at the S2 or the one that was recently announced. But yeah, this one is like, this doesn't really claim to have a lot of GPIOs. And that kind of shows, once we check look at the PCB, you'll see that there's not many GPIOs left, I think. Uh, yeah, so there's a UFL connector and a flexible PCB antenna. Awesome. And the GNSS also has a UFL connector and a patch antenna. Alright, so there's some customization that you can do when you're placing the order. Yeah, so Bluetooth connectivity is Bluetooth GPRS SMS call. I think one thing that's missing here is Wi-Fi because I believe the C3 has Wi-Fi. Uh, features. Yeah, I'm fairly certain this has Wi-Fi, so I think that's missing from the feature list here. Uh, but that's okay. People will be mostly using uh, yeah. So the Shin points out there's no Ethernet on the C series, which was a good feature to have on the ESP32s as well. Like I have a very nice ESP32, original ESP32 dev board, which has power over Ethernet, which is kind of handy. But yeah, none of these other, the newer ones have any Ethernet connectivity. And yeah, so this is an IP67 rated enclosure. Yeah, that's what I was wondering because it feels very rugged. I didn't see an O-ring, but maybe I might have missed it, or maybe this type of enclosure doesn't need one. But yeah, this is IP67 rated, so it's pretty good. Yeah, and there's some more info about. Okay, before we get to the getting started part, let's take a look at. Uh, let's take a look at. Yeah. Okay. This is. I don't know how to hold this honestly. How do I? Okay. Yeah. Okay. This is better. And I'm going to keep this here. Let's see if I can. Okay, this should be good enough. Yeah, so let's take this apart. I'm going to probably. I don't know how to do this. Yeah, okay. So this is four screws on the back here. It's all that you need to get that. O-ring is in the lid. Okay, perfect. So I didn't check the lid. I was checking the bottom part of the enclosure. That's why I missed it. Let's just take it out. Oh, by the way, there's a very nice feature. So the first screw is out. So if you can see, you can get open these two things, and then as you can see, perhaps it's not very clear, but there's like holes in here for mounting stuff. So when you're ready to mount, you can mount this and then hide the screws like this, which I found out while playing around with this, and I think it's like a really cool way to hide the screws. Yeah, there's I think there's three LEDs if I'm not wrong. We'll take a look at the schematic later, but I haven't ch checked the LED driver for that yet. I spotted I think three LEDs. Yeah, perfect. So this is the top part of the case. It says Valtrack V4 vehicle tracker, and as you can see, this cutout here so that the LED can be clearly seen. And as you can see, okay, let me just save these screws. I don't want to lose them. And as you can see, we have, all right, so this is the PCB. We can remove the screws, but before removing that, let's just take a look. This is the expressive chip. These are the LEDs that we were talking about, which align with the cutouts in the case. This is the nano SIM tray. Uh, this one is the USB connector. It's a regular micro USB connector uh, that we will use for programming. This is the modem, I believe. And yes, if you have questions, Ravi is in the chat and he's actively answering questions while I open this. Yeah, my particular one board has a sticky situation where one of the screw inserts is attached and I'm not able to remove it. So I'm just going to use it like that. I did open this up earlier today when I was checking it out, and yeah, okay, so this seems to be the modem, and I think this one is the GPS, sorry, the GNSS. Uh, and there's a bunch of passive components here. There's some UFL connectors, and I see four wires. These are the ones for the power rails. So this seems to be the one that's the battery connector. This is the UFL connector, I think, for the cellular modem. And then there's another two wires that go from here, which are for the 12 volt rail. There's another UFL connector here. I need to take a look at the schematic or the board diagram to figure out which one is which. But one would be for the cellular modem and the other would be for the GPS, I think. And there's two push buttons here. I'm not sure what they're for, but this says SW1 and SW2. That's fine. Valtrack V4 VTS ESP32S3. Perfect. Yeah, it's a pretty dense board. I think it's probably like a four-layer board. Uh, yeah, quite dense. Must be a pain to solder this by hand if he's doing that by hand. Uh, and yeah, let's take a look at some of the schematics and then we can come back to the hardware, I think. Right, so here's a schematic. Right, I'm going to open it in a new tab so that it's a bit more clearly visible. I would love if Akshay and Anul are interested in doing like one of the uh, open office hours for the PCP. I can read a schematic, but I'm not that great at hardware design. So if there's some feedback that we can give Ravi before his crowd supply campaign, that would be awesome. Yeah, so this is the A7672S, which is the modem that we looked at earlier. I think he has a couple of variants for different regions in the world. Uh, this is the SIM connector. This is the ESP32 C3. These are GPIO 9 and GPIO chip PU. These are the switches. So I think this SWT is probably like a user switch, and the chip PU is probably assigned to something. This is chip enabled, so probably, yeah. There's an oscillator external. There's power switches. There's UART connection, and let's find the USB. This is the battery voltage monitoring circuit. Nice, always handy. And yeah, this is the USB con, so this is connected to USB D and DP, which I think are there on the chip directly. This GPR 25 and 26. So that's good because then you save up on putting like a serial converter and stuff. There's USB ID as well. Awesome. And on page 2, I think we have the MP2617. I think this is probably the. I'm not sure what this is. Let's see. Switch mode battery charger. Sure. Okay. Yeah. So this is the battery charger circuit. Where's this? Yeah. The MP2617. And are we missing anything? No, that seems it. Uh, awesome. Yeah, I think for the size of PCB, it's pretty dense. You can take a look again if you like. But yeah, this is the PCB. I think he's mentioned the dimensions somewhere in the wiki as well. What we can do next is let's just plug it in. I'm gonna plug it in with my bench power supply. I already set it up to 12 volts earlier, so that should be good. I think it can take a bit more than 12 volts, but let's just stick to 12 volts. I don't think we need more than that. And I'm going to plug this in, and I need to make space for this. All right. And I'm going to disconnect this particular camera because I need some space. Awesome. And let's turn this on and see if we get power. No power yet. What have I done wrong? Okay. This works. I think I asked Ravi that question, Akshay, and I think he said there's not much left on the board. Right. Great, we have power. Uh, let's see if I can try and show this to you guys. Yeah, this phone camera thing is quite spotty and it's always a pain. Let's see if I get it working. No. Yeah, okay. Anyways, you guys will just have to assume that it's working. I can actually show this a little bit, but as you can see, the board is booted up, the LEDs are on, and it's connected to my laptop. And now let's take a look uh, at what's going on in the hardware. So, this one thing that I need to do. Yes, okay. So what I can just do is I can just say West Expressive Monitor, and that acts like a serial console. So even if this is not Zephyr code that's running on this device, I can use Zephyr's tools to just monitor, because that's eventually just serial, right? So that's what I'm doing right now. I'm using Zephyr's serial tools to just monitor what's is done. What Ravi is using is he's using ESP IDF, which is based on FreeRTOS, and yeah, that's the firmware. I think we haven't taken a look at that yet, but if you go to his wiki, he has a page explaining what firmware is being run and a link. It's pretty well commented, and there's a link to the GitHub where you can see that there's a C file and all of that. So yeah, there's a bunch of include files. I think there's the driver. I think we were discussing about that in the comments. The LED show up after 7 seconds. Yeah, the first time I booted up the board, I was wondering if I'm doing something wrong, but then the LED start. But yeah, debug data present, not really. Yeah. So yeah, there's not many pins left. If you're thinking maybe you want to add a relay, or maybe you want to connect some CAN hardware to it, because this is probably an automotive application. There's not enough pins here, so yeah, it's tough luck. But I think we can fix that somehow. Ravi, I don't think ESP bootloader should take that much time. Maybe that's something that I can take a look at when I'm looking at the firmware. Typically, it's pretty fast, 7 seconds. It feels like a bit much. But yeah, as you can see on my screen, we're getting some data. I think what's happening is it's not finding a network, because right now I don't have a SIM card put in. Uh, I have a SIM card here, a Geo SIM card with me, but I think we're running out of time because I wanted to keep it strictly to 30 minutes. But yeah, what we can do is we can quickly try and summarize, and what we can do on next Thursday is take a closer look at the firmware that's there already. So all of this, so this is all ESP IDF stuff. Uh, we can take a look at the firmware that is flash that's already available. We can see that on GitHub here. Uh, and then what we can do is we can start seeing how we can move this to Zephyr and help out Ravi add more software support, so that it's a bigger support pain for him. But yeah, jokes apart, I think it would be nice to have Zephyr support for it. And like I said, let me just quickly show this. There's already ESP32 C3 support in mainline. I'm not sure what release came with this, but I'm on the master branch and I can see I was able to try out this particular Espressif C3 board from M5 Stack with Zephyr earlier today. So it definitely does work. So that's great. So it's going to be pretty straightforward for us to add support for the Valtrack V4. And yeah, there's some stuff that I had to do, which Akshay did remind me of in the chat earlier today, is that there's some binary blobs that one needs to pull in to try out Zephyr. But yeah, there's a bunch of Zephyr's things that I would love to talk about, but I think I'm out of time for today. But yeah, this is awesome. I am pretty excited to hack on this board because it's from a developer that I can just ping on Telegram and ask questions. Uh, so yeah, Ravi, I think this is an amazing board. I'm pretty excited for the crowd supply campaign. Uh, Although I don't think we have a date yet, but hopefully it's in 2023. Let's see. But yeah, this is the Valtrack V4, and I hope this was a decent enough introduction for you guys. And next Thursday, unless anyone has any other ideas that they would like to talk about on this Hangout, unless anyone has any other ideas, I'm going to be hacking a bit more on next Thursday on the firmware front. Today we looked a bit at the hardware, and next time it's going to be all firmware. Awesome. I'm going to call it quits on the stream now, and thanks for joining in, guys. And let's keep the conversation going on Telegram.